Hello everyone, welcome to the lecture. Today's topic is basic blocks and flow graphs. A basic block is a sequence of non-consecutive statements in which flow of control enters at the beginning and leaves at the end without any halt or possibility of branching except at the end. See, sequence of statements, consecutive statements like this. T1 is equals to A star A, T2 is equal to A star B, T3 is equals to 2 star T2, 2 star T2, T4 is equal to T1 plus T3, T5 is equal to B star B, T6 is equal to T4 plus T5. These are the consecutive statements. So, this is a basic block. Basic block. The following sequence of 3 address statements form a basic block. Basic block will contain sequence of 3 address statements. For example, in the source code, A is equal to X plus Y star Z is a statement. This is not a 3 address statement. Now, we will convert this expression into 3 address statements. I will take a temporary variable T1. T1 is equals to Y star Z, that is, this expression is evaluated first, Y star Z is evaluated, the result is assigned to temporary variable T1. Then, another temporary variable T2 is equals to X plus T1. That is, T2 is equals to X plus T1. T1 derives Y star Z. Total X plus Y star Z is assigned to, result is assigned to T2. T2 will contain the evaluation of Y plus X plus Y star Z. Final assignment, A is assigned to T2. T2 is assigned to A. This is a basic block. Basic block. Basic block is a sequence of consecutive statements in which flow will enter at the beginning. Flow of control will enter at the beginning and leaves at the end without any halt, or there is no conditional and unconditional statements in between the middle of the basic block, but conditional or unconditional statement like go to will appear as a last statement in the basic block. Construction of basic block. Here we are going to partition into basic blocks. The given source code is converted into 3 address statements, set of 3 address statements, sequence of 3 address statements. Those sequence of 3 address statements is partitioned into basic blocks, sequence of basic blocks. So, here the algorithm is explained to find the basic blocks. The input for the algorithm is sequence of 3 address statements and output is a list of basic block. Input is a sequence of 3 address statements, output is a list of basic block. Each basic block will contain set of 3 address statements, and also each 3 address statements belongs to only one block, not more than one block. Same 3 address statement belongs to one basic block. Method. First step, we first determine the set of leaders in the basic block. That means every first statement is a leader. First statement in the 3 address set of 3 address statements, the first statement is a leader like this. This is the leader. T1 is equal to A star A. Here T1 is equals to Y star Z is a leader. The first statement is a leader. Then any statement that is target of a conditional or unconditional go to is a leader. For example, target of conditional or unconditional go to is a leader. For example, here we can label this 0, 1, 2, 3, 4, 5. Sixth statement label, that is T7 is equals to go to label 2. That means the control will go to statement 2. That means any statement that is the target of a conditional or unconditional go to is a leader. So, here T3 is a leader. So, target of go to in T7 is equal to go to L, go to 2. That means target of this go to statement is second, label 2. That is T1, T3 is equals to T2 star, 2 star T2 is a leader. Next, any statement that immediately follows a go to or conditional go to statement is a leader. That is, a statement that immediately follows a go to statement is a leader. For example, after this go to we have another statement T8. For example, T8 is equals to sum T6 plus C. This is also a leader. the statement immediately following a go to statement is a leader. The first statement is a leader. Second point, any statement that is the target of a conditional or unconditional go to is a leader, or any statement that immediately follows a go to statement is also a leader. And also for each leader, its basic block consists of the leader and all statements up to but not including the next leader or the end of the program. That means here T1 is a leader, this is a leader. So that the basic block containing T1 is equals to A star A is a leader is to these two statements. The basic block will contain leader followed by a sequence of 3 address statements until we will find a next leader. So this is basic block 1. So here this is another leader. This leader belongs to basic block B2. B2 will contain a sequence of 3 address statements until next leader. This is basic block B2. So T8 belongs to another basic block B3. T1 is a leader, so that T1 and T2 are basic block B1 because there is a T3 that is go to 2. So target of go to is for example here 3. So target of go to is label 3. So this is also a leader, so that the basic block B2 will start from here until we will find next block, next leader. This is basic block B2. Suppose there is another statement T8 is equals to T6 plus B. This is a leader, belongs to another basic block B3. Like that we can divide the 3 address statements into basic block. So the input for this algorithm is sequence of 3 address statements, output is list of basic blocks. To find the basic block, list of basic block, partition the 3 address statements to basic block, we need to find the leaders. So how can we find the leaders? The every first statement is a leader, and the statement that is target of a conditional or unconditional go to is a leader. Any statement that immediately follows a go to or conditional go to is also a leader. Consider this example. The following source code for dot product of two vectors A and B, dot product of two vectors A and B of length 20. This is the source code. Now we will convert this source code into set of 3 address statements. Here the first statement product, that is P, variable P is equal to 0, or prod is equal to 0, that is 3 address statement is also same as it is, prod is equal to 0. Next I is equals to 1, 3 address statement is also I is equals to 1. Then loop is there, that is do while loop. In this we need to there is a statement prod is equals to prod plus A of I star B of I. We need to evaluate A of I plus A of I first, then B of I, then multiply A of I and B of I, that is added to prod. Here first we need to write the 3 address statement for A of I. Here I is a index, that is integer. The integer variable occupies 4 bytes, that is 4 bytes. Every element stored in A of I will occupy 4 bytes. So that we need to write the 3 address statement for this A of I is T1 is equals to 4 into I. I is the integer variable index. So 4 means indicating 4 bytes. So every variable stored in A of I will require 4 bytes of memory, so that we will multiply 4 with A of I, that is assigned to T1, temporary variable T1. T1 is equals to 4 into I. Next T2. Now T2 is equals to A of T1. Here we are computing A of I. T1, A of T1 means T1 is 4 into I. So we need 4 bytes, so that A of T1 is assigned to T2, temporary variable T2 is equals to A of T1. Next evaluating B of I. T3, temporary variable T3 is equal to 4 into I, need 4 bytes, another 4 bytes for B of I. So 4 into I. Next T4 is equals to B into T3, T3 is 4 of I, so B of T3. So T2 is equals to A of T1, T4 is equals to B of T3. Next we have to multiply A of I into B of I. So T2 will give you A of T1, T4 will give you B of T3. So that T5 is equals to T2 into T4. Next, the result of this multiplication will be added to prod. So T6, another temporary variable T6 is equals to prod plus T5. T5 is T2 plus T4. T2 means A of T1, T4 is B of T3. T1 is 4 into I, T3 is 4 into I, like that. Next, then the result is the total prod plus A of I into B of I will be assigned to prod. So that prod is equals to T6. Finally, I is equals to I plus 1. That means I plus 1 is assigned to temporary variable T7. Finally, T7 is assigned to I. T7 will give I plus 1 that is assigned to I. Then condition, while I less than 20, if I less than 20 go to 3, that is target of this. If the condition is true, going to this 3, this A of I. So here if I less than 20, less than or equals 20, the control will goes to label 3, where we will calculate T1 is equals to 4 into 8. The loop will be repeated. Now we need to, this is set of 3 address statements. This is the set of 3 address statements. Now we need to partition this set of statements into basic blocks. So basic block 1 is statement 1 to statement 2. These two are one basic block because every first statement is a leader. Basic blocks are identified by identifying leader. So first statement is a leader. Then the target, see this, any statement, the rule that is the target of conditional and unconditional go to is a leader. See, there is a conditional statement, if I less than or equals to 20 go to 3. 3 is label 3, that is T1 is equal to 4 into I, that is a leader, that is a leader. This is also a leader. So the basic block, next to basic block will start from T1 is equals to 4 into I until go to statement. So this is basic block B1, this is basic block B2. So basic block B1 will contain statements 1 and 2, statement 3 to 12 will contain construct basic block B2. So two basic blocks identified for this given program. Next, flow graphs. Flow graph is a directed graph containing the flow of control information for the set of basic blocks making up a program. Here the nodes of the flow graph are the basic blocks. So here B1 is a basic block, B2 is a basic block. These two are the B1, B2 are the nodes in the flow graph. So this is B1, this is B2. The nodes of the flow graph are the basic blocks. It has a distinguished initial node. So this is initial node. Example flow graph for the vector dot product is given below for this code. These are the 3 address statements. 3 address statements are partitioned into 2 blocks B1 and B2. Now we have to give the directed edges for these basic blocks. How can we find the directed edges? Like this, B1 is the initial node, B2 immediately follows B1. So there is edge from B1 to B2. So B1 is the initial node and B2 is following B1. So in the given source code, the first block is B1, second block is B2, so that there is edge from B1 to B2. Next, the target of jump from last statement of B2 is the first statement of B2. So there is edge from B2. Here the target of conditional statement is if I less than or equal to 20 go to B2. Here I less than or equal to 20 go to 3, label 3. Label 3 will contain the statement T1 is equal to 4 into I. Here I will write if I is equals less than or equal to 20 go to B2. B2 means first statement. The control here there is edge from B2 to B2, last statement of the B2 to first statement of the B2. Next, B1 is the predecessor of B2 and B2 is the successor of B1. Like that we can construct flow graphs. The control will enter here and leaves here. Thank you.